thanks for clicking on this Prenarculus production. Today we are going to review how to operate on rational expressions, how to simplify rational expressions by adding them, subtracting them, as well as dividing them. All right, so let's get started. This is something you learned in Algebra 2. You've done it before, so let's review it and make sure that you understand how to do it. Okay, so this is an important skill that you're going to need this year, so let's start at the beginning. At the beginning, there was 2/3 plus 5/4. To add 2/3 plus 5/4, remember, if you want to add fractions, you need to have a common denominator. Right? You need to have a common denominator. So some teachers taught you to write them vertically. Okay, we could do it that way. So the common denominator between 3 and 4 is 12, right? 12 is the first number that both 3 and 4 go into evenly. So I'm going to make my common denominator 12. So I'm going to multiply the 4 by a 3 to make 12. So I'll have to multiply the 5 by 3 and make 15. And then to keep the fraction equivalent, 3 times 4 would give me 12. So 2 times 4 would give me 8. So now all I have to do is add 8/12 plus 15/12. And to do that, all I have to do is add the tops, right? Add the numerators. And that gives me 23/12. And that's the correct answer. Okay, I'm sure when you were in 5th grade, 6th grade, you had to write it as a mixed number. Here in pre-calculus, it doesn't matter to us. As long as it's simplified, if it were a 24/12, then you'd have to write 2. Okay, but 23/12 is fine. It's already in its lowest term, so to speak. So we'll accept this. All right. If you wanted to do it horizontally, maybe you learn to do it horizontally. That's the way I'm pretty much going to do most of these. So let's just show you what it looks like. If you had 2/3 plus 5/4, okay, the common denominator would be a 12. So down on the next line, I'm going to make my common denominator a 12. All right, I'd have to multiply the bottom by 4 here, the top by 4 there. So that would give me 2 times 4 on the top, plus 4 times 3, 5 times 3, so plus 5 times 3. You can make your life easier if you want to simplify that, the 2 times 4 and the 5 times 3 before you even get there. So that would give me 8 plus 15/12, which is 23/12. Same answer, just written differently. Okay, it's the same thing. All right, now, what happens if the denominators are not just numbers, they're actual polynomials? So I'm asking you now to add 5/x plus 3 plus 2/x minus 1. Well, the rules are the same. You need to have a common denominator. Okay? You need to have something that they both have in common. Well, this one is a little easier because when you have an x plus 3 and an x minus 1, you know for sure they're not the same thing. So the common denominator, to make the common denominator, you're going to have to put both of them in your denominator and multiply them. So I need an x plus 3 times an x minus 1 in my denominator. So now, my first term, it says 5/x plus 3. There's already an x plus 3 in this fraction's denominator, so it needs the x minus 1 to make the common denominator. This is the common denominator. I need them both. So I'm going to write 5 times x minus 1 in the numerator. Plus, bringing over this addition sign, we have 2/x minus 1. Well, this denominator already has an x minus 1, but it doesn't have an x plus 3. So I'm going to multiply the top and the bottom of the second fraction by x plus 3. So I'm going to write 2 times x plus 3. I already put my addition sign in here. That's good. And now I'm going to simplify the numerator. I'm just going to distribute and combine the like terms. So that would give me a 5x minus 5 plus 2x plus 6 all over x plus 3 times x minus 1. And we're not going to actually FOIL out the bottom or double distribute in the denominator here. We're just going to leave it be. Okay, you're allowed to leave that there. There's no simplification that you're going to get out of it. So we're just going to leave it the way it is. And we're just going to combine the like terms in the numerator. The 5x and the 2x make 7x. And the negative 5 and the positive 6 make a 1. So we have 7x plus 1 over x plus 3 times x minus 1. And this is the correct answer. This is all done. Okay, that's how you add two rational expressions with an uncommon denominator. All right, let's keep going. Let's try to subtract two rational expressions with an uncommon denominator. So now I'm asking you to take 2 over x minus 5 and subtract 3 over x. So the first thing you need to do is you need to come up with that common denominator because my denominators are not the same right now. So again, this first term has an x minus 5 in its denominator. The second term has an x in its denominator. These two terms are not the same. These two polynomials, x and x minus 5, they're not the same. So I have to have both of them in my common denominator. I need an x there, and I need an x minus 5 in that common denominator. So let's come up here and see what we're missing. Okay, so here's my common denominator, x times x minus 5. My first term is 2 over x minus 5. So the common denominator is missing an extra factor of x. So I have to multiply the numerator and denominator by that extra factor of x. So my numerator term is 2x. Bring over that minus sign from here, bringing that down there. All right, now my second term is a 3 over x. So there's an x in its denominator, but it doesn't have the x minus 5. So I have to multiply the numerator and denominator by that x minus 5. And I'm going to write 3 times x minus 5. And now I'm going to distribute my negative 3 to both of these. And then I'm going to clean it up, and we'll be all done. We have 2x minus 3x plus 15 over x times x minus 5. So that is negative x plus 15 over x times x minus 5. And this is the answer. I can't do any more with this. I cannot cancel this x with this x because this x is under the operation of addition with 15. You cannot cancel under addition. So these cannot be canceled. Okay, do not make that mistake. All right, this is the correct answer. My correct answer is complicated. Sometimes in math, the correct answer is complicated, not simple. All right, so that's how you subtract two fractions with uncommon denominators. Okay, now let's try to divide two fractions. What if I ask you to divide negative 2/5 and divide it by 4/3? All right, so now I think the easiest way for us to handle this is to go back to what you did in 6th grade. If we read this problem as we would have in 6th grade, it would say this, and write it as well. It would say negative 2/5 divided by 4/3, right? That's exactly what this problem says here. Okay, it says take negative 2/5 and divide by 4/3. So we wrote the same thing down here. Now, in 6th grade or so, you probably learned how to simplify this. And you would do it, okay? You probably learned it as you keep the negative 2/5 where it is, you change the division sign to multiplication, and then you flip the 4/3 over and make it 3/4. And then you can multiply straight across, because when you multiply fractions, you multiply straight across, and you'd have negative 6 over 20. Which can be reduced, right? I can put it in lowest terms. 2 goes into each one. So I'd have negative 3 over 10. And that would be my correct answer. Okay? There's also another way to reduce the negative 2/5 times 3/4. I can also cross-cancel this because they're multiplied. The 2 and the 4, they actually go into each other. One's in the numerator, one's in the denominator. 2 goes into itself one time. 2 goes into 4 twice. And then if I do negative 1 times 3, that's negative 3. 5 times 2 is 10. And I get the same answer, negative 3/10. You can do it either way, whatever makes you happy. All right, let's try this second one here with numbers as well. And then we're going to go on and do it with an expression. So we have 2/7 divided by 5. So let's try to write it 6th grade style. That's 2/7 divided by 5. Okay, so I'm going to keep the 2/7 where it is, change the division to multiplication, and I'm going to take the 5 and use its reciprocal. Well, 5 is really just 5 over 1, so its reciprocal is 1 over 5. So now I'm going to multiply. I can't cross-cancel anything, right? There's nothing that divides in evenly. So I'm just going to multiply straight across. 2 times 1 is 2. 7 times 5 is 35. 2 over 35, that's the answer. This is done. All right, now let's see how it works with an actual polynomial expression. Let's try to take 2 minus x over 2x and divide by x minus 2. Now, this is something you're actually going to see fairly soon in this course, pre-calc at least. And it involves one of the steps in simplifying the difference quotient. So you're going to see this coming up, and you'll have to be able to simplify it. Okay, so let's take a look and see if we can do it. So we have, let's write it down 6th grade style. We have this fraction, right? The 2 minus x over 2x, 2 minus x over 2x, divided by x minus 2. That's what this says. That's exactly what this says up here, right? Okay, so now let's keep the first one where it is. Change the division to multiplication. The x minus 2 needs a 1 underneath it, so that we can flip it over and write 1 over x minus 2. All right. Now, we're going to multiply straight across. There's 2 ways you can do this. You can cross-cancel as well if you see it. But let's multiply it straight across first. But I'm not actually going to multiply the denominator out because my goal is actually to get one of these terms to cancel. So 2 minus x times 1 is 2 minus x. And then I'm just going to write 2x times x minus 2. So now, if I look, I have 2 minus x in the numerator, x minus 2 in the denominator, and there's multiplication between the 2x and the x minus 2. I'm really tempted to cancel these two, but they're not the same. They are really close, though, right? 2 minus x and x minus 2. They are really close. The only difference between the two is the 2 here is positive. Down here it's negative. The x here is negative. Down here it's positive. So what I can do is I can factor out, as a GCF, a -1. I can do it from the numerator term, I guess. It's a little easier. If I take out -1 from the numerator, it would give me, well, the 2, which is positive, just changes to a -2. The x, which is negative, just changes to a positive x. And then I'll leave the denominator the same. And if I look, now I could rearrange this, right? I could take this term that's up here and just switch the two. Instead of writing -2 plus x, if you'll allow me, I'm going to write x minus 2. It's the same thing. Okay, it's just written the other way. And now these two terms, they are the same. Under multiplication, they would cancel. And I'm left with -1 over 2x. And this is the correct answer. This is something you're going to have to be able to do coming up very quickly when we talk about the difference quotient. Recognize that these two, well, first of all, simplify this. Then recognize that these two, this 2 minus x and this x minus 2, are almost the same. But if I take out a -1, I can make them the same, and then I can cancel them out. So this is my correct answer. And this is how you simplify rational expressions by addition, subtraction, and division. All right, as always, thanks for clicking.